Hi there, thanks for watching this video. This is Mr. Bowman, and in this video we're going to talk about quadratic functions. So here is the definition of a quadratic function. A quadratic function is any function whose equation is of the form y equals ax squared plus bx plus c, where a is not 0, and where a, b, and c are these real numbers, and that should look familiar to you. That's the same definition we gave previously to a quadratic equation. This form of something x squared plus something x plus something else is generally what we call a quadratic form. It's worth talking about for a second why a can't be 0. If a were 0, 0 times whatever x squared is for any x would just give you 0, and this term wouldn't be there. And then the function would just be y equals something x plus something. And we talked a lot about those earlier in the year in Algebra 1. Those are linear functions. So it's important that a is not 0. Here's one quick specific example. So the function y equals 3x squared plus 5x minus 2 is a quadratic function. And in this specific example, the value 3, the coefficient of the x squared term, is a. The b, the value of b, is the coefficient of the x term. Whoops, oh, blue. It's a positive 5. And c, the constant term, the term without x in it, and it's important to get that negative sign in there, is negative 2. So we're going to talk today about what the graph of a quadratic function looks like, and those are called parabolas. So this is what the parabola looks like. Every parabola will look something like this. It's important to note that this is not a linear function. It's not that the rate of change is always the same. In a linear function, you could always do like a pattern of up some number and over some number to get to another point on the graph. If a line had a slope of 2, you could always go up 1 and right 2 and get another point on the graph, and up 1 and right 2 and get another point on the graph, but that doesn't work here. Check it out. Suppose I start at this point at negative 2, negative 3. If I have to go up 3 and right 1 to get to the next point, the pattern's actually different. Up 3 and right 1 takes me too far. For this one, I actually have to go up 5 and right 1. And there are some cool patterns you can find in these functions, by the way, that are kind of like slopes, but they're just not always the same slope. So we want to talk about what some of the key points in every parabola are. Now, if we were going to be together this year physically, we would have spent a lot more time working on letting you practice making these graphs on your own. We're going to try and highlight the important things you need to know about the graphs today. One thing you need to know is that every quadratic function has a point called the vertex. And the vertex is like the turning point of the graph. It's going to be either the highest or the lowest point on the graph, depending on whether the parabola has, the two open ends that are going on forever and ever upwards or down. In this case here, the vertex, that key turning point, is right here. So in this example, the vertex is a point. It's an ordered pair. It's when x is negative 3 and y is negative 4. The vertex is negative 3, negative 4. Now, another important feature, and really I know it says key points up here, this is not really a point, it's not really part of the graph, is that every parabola will have an axis of symmetry. It's a vertical line through the vertex, vertical meaning, straight up and down, like this. It's not part of the graph, but it does divide the parabola into two equal halves. It's a line of symmetry for the quadratic function. So the vertex was down here. Do you see we've drawn it in for you this time. It won't always be sketched in for you. But this vertical line here, we drew it in as a dotted line, is the axis of symmetry. That line equation, it's the line where every x is negative 3. The axis of symmetry is the line x equals negative 3. So let's talk about the x-intercepts. When we talked about linear functions, the x-intercept was the point where the line crossed the x-axis, and that's still true here. The x-intercept, or x-intercepts plural, are the point or points where the parabola touches or crosses the x-axis. Remember that the x-axis is the line right here, the line where y equals 0. We also sometimes call these points the zeros of the function. It's worth pointing out that not every parabola has x-intercepts at all. Some of them don't cross the x-axis. Some of them only touch it at one point and have just one of them. But many of them will have two x-intercepts like this one does. I see this point right here and this point right here. So in this example, the x-intercepts, plural, are this point. That's negative 5, 0. And what's the other one? Negative 1, 0. All right, kind of the last key important point that you need to be able to locate on a parabola is the y-intercept. And this, just like with linear functions, is the point where the parabola crosses the y-axis. So recall that the y-axis is the vertical line where x is 0, right here. So can you tell where this parabola crosses that? It can be hard to tell sometimes. This time we made the point a little bit bigger for you. It's right there at y equals 5. So what is that point? When x is 0 and y is 5, the y-intercept is the point 0, 5. Let's practice this. Here is a parabola, a quadratic function. And it's worth pointing out that this one actually opens up the other way. The example we looked at previously opened upward. The parabola had the vertex at the bottom of the graph, and it went on and on forever in the other direction. This one's the other way. At this point, the vertex is like the very, very top of the graph. Right here at this point here, the turning point in the graph. And what I mean by turning point is, if you were going to trace this graph from left to right now your pencil is moving up, 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 but right at that point, right here, now you're going to start bringing your pencil back down, 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 down. So the vertex is right here. What is that point? It's where x is 1 and y is 4. It's the ordered pair, 1, 4. The axis of symmetry wasn't drawn for us, but it would be the vertical line that goes through the vertex. And since it's a line, we should give it a line equation. That's the line where every x is 1. Let's write x equals 1. Are there x-intercepts? Yes. The x-axis is right here. I see it crossing both here and here. Let's list them both. This is the point negative 1, 0. And this is the point 3, 0. Can you find the y-intercept? Yeah, it's right here. The y-intercept is where the parabola crosses the y-axis, the vertical axis. That's when y is 3, and when y is 3, x is 0. That's the ordered pair 0, 3. Thanks for watching.